All right, ladies and gentlemen, there are, let's see, two things I'm going to do on this video. Number one would be to work problem 2 on OAS 39, and then I'm going to do the last example in that note sheet, which is finding the orthocenter given a triangle, and then you'll have to do one on your own. Hopefully this will aid you because you can rewind and keep thinking about this and really attack it. So for problem 2 on OAS 39, number 2, you are asked to find the circumcenter of this triangle. Triangle with coordinates -9, -1, -7, 1, and -2, 1. Now, the circumcenter is the point of concurrency of the perpendicular bisectors of a triangle, the sides. So if we're looking for perpendicular bisectors, we would need to find the midpoints of two sides, and then I would need to find the slope of the line that is perpendicular to each respective side. So I have a feeling that most of us focus in on working with segment AB and working with segment BC. You could have chosen segment AC, but let's just go there. I particularly like segment BC because that slope is 0, and that's going to make life a little easier for me in many respects. So I really want to find the equations of the perpendicular bisectors of these two sides. So I'd need to find the midpoint, and then I would need to find the slope of that line that would be perpendicular. I need to find the midpoint, and I would need to find the slope of this line. And notice physically that my circumcenter is actually outside the triangle. And you know what? That's okay, because a circumcenter can be outside a triangle. It could be actually on one of the sides of the triangle, and this would also apply for the orthocenter. The centroid always has to be inside the triangle, and the incenter would also have to be inside the triangle. So if I have these, this setup, I think first I would want to find the midpoint of segment BC. To find the midpoint, remember the x-coordinate of your midpoint would be the average of your x-coordinates of the x-coordinate of the midpoint would be the average of the x-coordinates of the endpoints. The y-coordinate of your midpoint would be the average of the y-coordinates of the endpoints. So for BC, I'm taking -7 plus -2, which is -9, divide by 2, I get -9/2. For my y-coordinate, I would take 1 plus 1 divided by 2, and that's 1. You could have also said, hey, think about this. My y-coordinate's the same on both endpoints. Wouldn't the midpoint have to have the same, the very same coordinate? And we do know that. So in my organization, I'm looking at segment BC. In my organization, the midpoint of segment BC has coordinates -9/2, 1. That makes me happy. Now let's go and think about finding the slope of this line, the line that's perpendicular to segment BC. Well, the slope of segment BC is, you see, it's the slope of 0. If I take my change in my y's divided by my changes in my x's, ladies and gentlemen, I do indeed get 0. So if segment BC's slope is 0, what would be the slope of the perpendicular? Well, robotically, you all think, hey, perpendicular lines have slopes that are opposite reciprocals of one another. But in this case, -1 divided by 0, we don't really manipulate representations that look like that. But we do know that the slope of that perpendicular line would be undefined. So we'll think about where that goes as the day progresses. So the slope of my perpendicular would be undefined. Now, undefined slope, that would mean that we'd have a vertical line. Vertical lines, remember that vertical lines have equations x equals some real number. Horizontal lines have equations y equals some real number. So, if we were going back to the example at hand, and we want to define the equation of the line containing segment BC, since its slope is 0, we would know that it's a horizontal line, so y equals 1, which is always what the y coordinate would be for that line, would be its equation. In our example, we're going to be using x equals some real number. Well, x is always this negative 9/2. So this right here is the equation of the perpendicular bisector of segment BC. I'm having some orientation issues, but that's okay. Now, the next thing I need to find is the midpoint of segment AC. The midpoint of segment AC would require me to take the average of your x's, which you have your -9 plus -7, which is -16, divided by 2 is -8, and the average of the y's. -1 plus 1 is 0. 0 divided by any real number that is not 0 would be a whopping 0. Therefore, the midpoint here has coordinates -8, 0. And the slope of the perpendicular, well, we need to find the slope of the actual first. The slope of line segment AB is equal to 1 minus minus 1 divided by -7 minus -9. Last time I checked, that's 2 divided by 2, which is 1. And you can see that confirmed here. If I'm going from point A to B, I go up 2 to the right 2. 2 divided by 2 is indeed 1. So if this line has slope 1, what would be the slope of its perpendicular? Well, that in fraction form is 1 divided by 1, so the slope of the perpendicular is the opposite reciprocal. So -1 is that slope. So let's organize ourselves. This is -1. We have a point, we have a slope. Therefore, we are definitely in line to find the equation of the perpendicular bisector of segment AC. I take my y minus 0 equals -1 times x plus 8. So this is the equation of the perpendicular bisector of segment AC. Now, I see a system of equations. This system of equations allows me to solve it because I know I have 2 variables and I have 2 equations. Therefore, provided I don't have parallel lines, and my lines are going to intersect on that plane, I'm going to find one and only one real solution. So in this sense, I have x is equal to 9/2. I mean, I have my x coordinate. So now I just plug it in. I take y minus 0 is equal to -1 times -9/2 plus 8, and that into eighths is into halves is 16/2. So last time I checked, I have y equals -1 times the quantity 7/2, and so that's minus 7/2. So that means that my x solution is -9/2. My y solution is a -7/2. So the point that is the circumcenter of my triangle, or triángulo, if you want to say it in Spanish, is -9/2, -7/2. That's the circumcenter. And we can see that if we were to go to Sketchpad and we were to clear our mess here, and I were to go and I were to have a tool that actually finds the circumcenter, I could select the vertices of my triangle, and then I could say, hey, let's measure the coordinates of that point. Oh my, where did I go? That's just silly. If I look what that is, that's a negative 4.5, negative 3.5. And last time I checked, that, and I'm trying to write circumcenter, would be minus 9/2, minus 7/2. And you can say either of those. What are the geometric implications here? Well, this center is the center of the circle that would go through those three vertices. And ladies and gentlemen, is that not beautiful? You did that. That's what you need to do. Don't you love this country? Now the next example I'm going to do on another video. Thank you for shopping. Bye-bye.